Okay, so we've co-registered the T2 to the EPI, all right? So these two are in the same geometry, the same space now. Note that the subject, the way we acquired the scans, we already made sure or tried to maximize that the T2 and the EPI are coplanar. We talked about this, right? They were acquired back to back, and we copy the geometry of the T2 for our EPI. So the two kinds of images should be acquired in the same space. All right. The problem is that that makes the T2 sort of limited. You can see that and we talked about this also before, that the resolution of the T2 is good in plane, in XY plane. But you can see that in the Z plane, the resolution is bad. Okay, that's because it's just copying the geometry of the EPI and it's just doing 32 slices. It's not doing an isovoxel kind of situation. All right, so the structural information in this direction, in the Z direction, is not very good. And also, it's just 32 slices. So this is okay for us to kind of just localizing the structure of the EPI activity that we will see, subsequently. But if we want to do things like uh, spatial normalization, where we want to move or kind of deform or normalize this person's brain to like a template, kind of like a common atlas that everyone uses. Okay, so that you can match everyone's hippocampus in the same space in the same coordinates, right? That's where we will use the T1. And remember, the T1 that we acquired was isovoxel and high resolution in all three directions. All right. Now, the T1 was not co-registered to the T2 or EPI. Okay, it was acquired, and it could be acquired. You could even take the subject out, put the subject in, and then of the scanner, and then acquire a T1 on a separate occasion. All right. But it doesn't matter so much as long as the time period that you acquired the scans was relatively close together, so that it's not like the subject's brain had changed structurally, right? Yeah, so you can do that. Acquire the T1 and the EPI and the T2 at different time points, and then you can do the co-registration. And that's what we're going to do now. So that you can use not only the temporal resolution of the EPI, and which is now matched to the structural resolution of the T2, you can then match the T2 structural resolution to the T1 isovoxel resolution, all in all directions. And so that when you bring all these together, you can then kind of use the T1 to match to the common template that everyone uses, because it has very good structural information equally in all three directions. And then you can use that also to then bring your EPI to that common template as well, as we talked about in class, right? There are many, many different ways to do this, but here we are, doing it in our most common sequence in the lab. So we already co-registered the T2 to the EPI. So now our EPI can leverage on the T2 high resolution, high structural resolution, right? So therefore, we can then use the T2 and as the base image now, and kind of co-register the T1 to the T2. If you can do a co-registration of a T1 directly to an EPI, but that won't be as good as in theory, that won't be as good as co-registering a T1 to the T2, because both of them have higher spatial resolution, right? So that's why we're doing it this way. We're trying to minimize error and trying to be as precise as possible by using all the information that we have as efficiently as possible. Sometimes you don't have the T2, so if you don't have a choice and you have to co-register the T1 to the EPI directly, well, that's the best you can do if you didn't have that image. So that's fine, all right? But if you do, then it's highly encouraged for you to do what we are doing now, which is we have co-registered the T2 to the EPI, and now we want to co-register the T1 to the Coregister T2. All right, so this is the same step as the co-registration step we already did from the T2 to the EPI, but we're going to change things up a little bit. Again, co-register, we just need to estimate. And in this case, the reference image now, so if you understood what this means, the reference image now should be the T2. It's already the co-register T2. It's already been moved to the common space as the first volume of the first EPI run, so we don't want to move it anymore. Okay, so that's now the image that stays still. So Y01 T2 is now the reference image, the co-register one. And again, as I mentioned, because it's estimate, there's no change in the file name, only modified dates and times, right? But if you are aware of what you did, you should be okay. You should be confident that this is the right file. If you're not, go back and think about it. All right, never do anything and then you're not sure, and then it might end up being an error. In this case, we just did it, so this is the correct file to select. And the source image is the image that's moved, and as we said, the T1 is the one that's moved to match the T2. So we're going to go ahead and select for this subject the T1 image. And that's that. It's very simple. All the others remain the same. No other parameter changes needed at this point. I'm just going to save this batch. I'm going to put it in the right place now. And it's going to be coreg the T1 to the T2 this time. Okay. And it's green, so just click and play, and that's it. That's as simple as it is. I'm just going to let it run so you can see the outcome after it's done its job. Similarly, there's the joint histogram, and here on the left is the stationary image, the reference image, and then this is the image that's moved. So you want to just do a check. The intensity of the T1 is not so good, but you can still see it. So work a little harder, and you'll see that it's done its job. Okay, left, right, front, back, up, down. In this case, there's very minimal distortion because these are not like the EPIs. The EPIs are particularly susceptible to distortion, so you don't have that problem here. You can see that it's very well behaved. And you can click the ventricles and the corpus callosum, and you'll see that it's really quite well done.